All right, so Mistral 3.1 just dropped, and everyone's talking about how this 24 billion parameter model is crushing benchmarks against Google Gemma 3, OpenAI's ChatGPT 4o, and some others. But does it really live up to the hype when you're running it on your own hardware? So after spending some time testing it and tweaking it in our system on my DIY AI server, I've discovered some interesting limitations, and I kind of want to talk about it today because the benchmarks look really good. So especially when it comes to memory requirements. Today, I'm going to show you exactly what this means. If you want to try to use this in your local development on your AI PCs, let's dive in. Welcome to Startup Pack. I'm Spencer Thomason. Here at Startup Pack, we love to train software developers in our licensed coding boot camps, as well as to build custom software solutions for companies. With a decade of executive leadership as a fractional CTO and 25 years of software development, I've mastered transforming tech teams and products. All right, so Mistral 3.1 has launched, and I want to go over their site release here with you guys and talk a little bit about this today because I think their release is really interesting, and you all know that I'm really interested in these small models. So I want to go over some of these details here. So Mistral Small 3.1 got released, and this new model comes with improved text, multimodal understanding, and an expanded context window of up to 128K tokens, right? So 128,000 tokens. The model outperforms comparable models like Gemma 3 and GPT-4o Mini. Now, they've gone through and they've showed, modern AI applications demand a blend of capabilities. And they go through this. It says below you'll find more details on model performance. And it goes through and looks at each of these benchmarks. So as you go through these, you can see that for simple QA, and they go through each of the individual benchmarks. Now, I'm not a huge benchmark fan, but I know that we need to pay attention to these. But it seems like there's a constant battle with just these very, very marginal gains on each of these. Now, the multimodal, that's hard to say 10 times fast, instruct benchmarks here are really interesting. And I think as you look at these are going to be interesting as we move forward. I think multimodal is going to be a big thing as we start to build into AI agents. Long context is going to be really important as we move into it. And so ultimately, I kind of just want to dive into these key features and capabilities. You guys can all look these up and look at these those benchmarks if that's really what you're looking for. But I like these key things here, right? So lightweight, Mistral Small can run on a single RTX 4090 or a Mac with 32 gigs of RAM. Now, in my experience, running on the 32 gigs of RAM is really slow and nowhere near the speed of running something on the GPU, right? Now, your fast response conversational assistance, this is ideal for a virtual assistant or other applications where quick, accurate responses are essential. And then it goes through some of these other pieces where you can fine tune it. It talks about the foundational for reasoning. And this was really, really interesting, but it says that it is available everywhere. And where I, of course, am going to jump to quickest is I'm going to go to Ollama and check this out because that's always my go-to source for when I want to just spin up something really quick. If you're going to dig down into the weeds and you want to really eke out performance, Ollama may not always be the fastest, but it's pretty good for what we're needing in most of our cases. Now, one of the very first things you notice here is that this shows 15 gigs in downloads. So my very first take on this was I was thinking, this should work pretty good on my DIY AI PC, the server that I've built. So if you've been following along my channel, and if you haven't, then definitely make sure you leave a comment down below because I love to hear you say hi. But also make sure you check out my AI DIY server or PC build because I give you a step-by-step breakdown on exactly how to build an AI server that you can run for your business or for your development needs for under $500. So I did a ton of research and I pieced together something that is super powerful. So I'm going to show you some of that, and actually we'll be using that model as I talk about these here. So the Ollama model here is what we're going to run, and I'm going to get this up and running because I want to show you what my exact findings were for some of these as I start to dig into it. Now, again, I'm going to use the findings using my DIY AI server that I've built. And again, check out the link here because that's down in the description down below because I'm going to show you exactly how I built this out. So when you're wondering what I'm running against, this is what we're running against here. Now, as I switch over here, I'm going to actually go ahead and take my face off this so you can see the whole screen here because I want to let you be able to see that. So as we switch over to this here, sorry, it took me a couple tries there to get that scene correct. As we do this here, I want to actually show you. So Ollama list. So we can see the different models that I have running here, and get this a little bit more readable. So you can see I've downloaded quite a few different things. Now, the three that I really want to pay attention to here is the Gemma 3 27 billion, which on disk sits at 17 gigs. The DeepSeek R1 32 billion parameters, which sits at 19 gigs. These seem to be some of the closest competitors from what I've seen, at least in the ones that are most popularly available on Ollama here. And then obviously the Mistral 3.1 that we're seeing here. Now, this was 15 gigs. So just by looking at the size of this, and I know that's not always apples to apples, but just looking at the size of this, I thought, we should be pretty close here. So we're going to do Ollama run Mistral, if I could type Mistral -small 3.1. Oops, except I forgot one of the most important parameters, verbose, because we're going to be doing some speed testing here. Now, the verbose nature will slow it down if we're actually running for production, but in our case, we need to see what this is running. So why is the sky blue? If you've followed my channel, you see this is my general prompt. So now on this side, I'm going to run and check, and I want to see how this is running. Now, one of the first things that I noticed, unfortunately, which I'm going to have to resize these here just a touch for you guys to see, is you can see that we're now running, and unfortunately, it's 15% running on the CPU and only 85% running on the GPU. The size on this is a whopping 27 gigs. Now, I'm going to keep that up here for a minute because this is going to get important as we look at some of our comparisons against, like I said, against Gemma 3, like 27 billion, or the DeepSeek 32 billion parameters. Now, it's possible that this is going to run more accurately, but because of this on this system here that we're using as kind of our benchmark, because again, I want something that is the real man, something that you can build for $500, host into a hosting closet, and that you can still run some of your agent workflows against. And so this is only running at 5 tokens per second. That's a pretty slow. So if I'm running the same thing with one of these other models that we're comparing to, so let's grab Gemma's Gemma 3 27 billion here. So Ollama run this. Now, when we're running this one here, and it's going to take it just a second to get started. And again, I'm not running this even on my machine. I'm running this on this server here because the server is a little bit more hardware than I have that I'm running here. So it's taking just a minute to get this guy up and running. And why is this guy? Oops. And I already forgot to add my prompt so we could see our benchmarks. Why is the sky blue? Now, when we run this here and we go look at this, you can see that even though it has more parameters, it's actually larger size of parameters. This 24 gig is only running 5% on the CPU and 95% on the GPU. So, and again, sometimes I can actually get this to run just right on the edge. I can get the Gemma 27 to run on entirely GPU. There's probably a couple of things I need to shut off on the system. If I do, I can usually get it right to where this model will squeeze in entirely to the GPU. Now, that's pretty good because when you see this come back then, once this finishes up here, and I'm going to pause this just for a second so it can finish up. So you can see we're running actually double the tokens per second because of that difference to it being loaded into the CPU. Now, even 10 tokens per second is nothing to write home about, right? Probably fast enough for an AI agent if you're running this, but that's still gonna be pretty slow and definitely not really fast enough for conversation, right? The conversation definitely isn't gonna be fast enough for that. So let's jump out of this one here and get back to one of our others. So the next one I want to try is the DeepSeek 32 billion. Now this has a much larger parameter, but one of the things DeepSeek, as we all know, is super good at is how efficient they are. So by running this guy here, and again, it's going to take just a second to get this loaded up into memory, swapping these in and out of memory, and I'm doing this, pretty much real time for you here, pausing occasionally, but now we notice that this size is 23 gigabytes running at 100% on the GPU. So this will take a second to get loaded up because what it's doing is loading the model into the GPU memory. And I already did it again, where we want to actually get it loaded with the verbose so we can see the benchmarks. And why is the sky blue? Now, this actually gives us a thinking, right? So it gives us a little bit of a think. Then it's going to come back and it's going to return with this. Now, again, running 100% of the GPU, you can definitely see we're getting closer to conversational speeds here, pretty much pushing right to the edge of the limits of what we have here. And there's probably a couple of things that we could shut down on this machine to get it to run a little bit faster. Let's get to those benchmarks really quick. All right, so we can see this one's running at 12.85 tokens per second. Now, still much better, and I know that as we get into more of my in-depth testing with actual data matching or image processing or any of those, I definitely found that the ones that run 100% in the GPU run much more efficiently. So this was one of the first things that I ran into as I started to test out the Mistral Small 3.1. The biggest problem that I'm seeing here, just for those actually needing to run this. So again, this machine that I was just testing on, $500. Basically, it's a few years old, 4 or 5 years old of a machine with a 1080 Ti plus a 3060 card into them. And so again, running right around $500. Whereas in order to be able to run Mistral Small 3.1, you need to have a pretty significant card, because this would require to have at least 32 gigs of RAM. Because when we saw that it loaded up, it required 27 gigs of GRAM. This is where you would need to see this run on something with 32 gigs of GRAM. Now, right now on as of today, when I was looking, the cheapest that I could find, one of the 4090 cards, which is the smallest, the cheapest card that I could find with 32 gigs of RAM, I was finding that right around $4,000. So, I mean, that's a pretty hefty jump to go from $500 to $4,000 when the comparison models could run much faster. So is it possible that Mistral runs more effectively? Absolutely. Mistral claims it can be run on a MacBook with 32 gigs of RAM. I think those right now are also running for about $1,500. I don't think that you're going to see that I think you're going to see dramatically slower than running on the GPUs. So what's interesting is both DeepSeek R1 and Gemma 3, more than double the performance on it with the same size of memory. Now, despite the memory challenges, I was able to test the model using cloud instances and sufficient RAM to evaluate it, and it does perform really well. Now, side by side, to me, the performance on accuracy between DeepSeek's R1 32 billion model and Gemma 3's 27 billion model, to me, were very negligible. So the difference in the hardware costs that I'd have to run to be able to run it, basically you need an RTX 4090 in order to really be able to run it. In order to get that to happen, I really truly, I didn't see any difference in the results that I was getting back. And so despite the hardware limitations, Mistral 3.1 does seem to have some compelling cases by their argument. I didn't get to test it a ton just because I didn't want to run a ton. I'm kind of cheap on this kind of stuff, because I really like to build stuff that is real, that a real developer can start to look at. So to me, the real alternative here would be, to me, DeepSeek's R1 32 billion model parameter wins. Gemma 3's 27 billion model parameter also would win, because those are things that I can run on something in the $500 to $600 range. Now, if your company is looking to build out systems that aren't connected, or if they're trying to build out some AI agents and you want to dive into a specific use case, reach out to us, because here at Startup Hack, we love to build software, custom software for companies. So check out startuphack.com/Spencer, because we can help you out. Now, despite a little bit of my criticisms, I love that people are working on these smaller models. I think that Mistral just missed just a little bit to get it down under that 24 gig limit. I think there's a pretty far gap between the 24 gig limit and something that's going to require 32 gigs, which is the next step up. Unfortunately, the difference in the cost right now is you can pretty simply put together a system that has 24 gigs for between $500 to $1,000, whereas there's a huge jump up to that 32 gig range to get into the $4,000 to $5,000. That's just a pretty big jump for most small businesses or developers who are just looking to try to get off the ground. So I think from a business perspective, from the business standpoint, the high hardware requirements makes Mistral Small 3.1 just out of the reach of most SMBs. Again, 4,000 isn't totally crippling, but like 4,000 to 5,000 is a pretty good investment. Whereas right now, I think a lot of businesses are still trying to feel out what they're going to do with their AI implementations. And so I think when you get into a range where you're spending that much, I think it becomes difficult for businesses to justify, whereas a $500 investment is something that pretty much anybody can put together. So, my final verdict is that the Mistral 3.1 Small represents impressive technical achievements, but falls just short. And I think if they could get it under the 24 gig optimized in these areas, that I think they could see it run a lot better. Now, they did say something that if you quantize it, sorry, I'm not saying that correctly. They did say that that the large models are limited to quantization. Sorry, I can't say that one fast. And if you can get it to the quantization, they say you can get it under the 20 gigs. I wasn't able to get it there. And again, I didn't invest a ton of time into it. But again, for most people, I think we're going to, run some of these models pretty much out of the box and try to build against them. Now, as always before, make sure you check out our DIY AI, PC, or server builds and the playlist that we have for that, because we provide tons of free code samples. And so make sure you check those out so that you can be working against these code samples. We're going to drop another one next week that's going to be all about how to build against these Ollama models like how you saw me running today. So I'm still optimistic about Mistral's future models, and I'll be watching really closely to see if they can get them under that 24 gig mark. Now, what are your thoughts? Do you agree? Do you disagree? I love to have a great discussion. So reach out, because here at Startup Hack, we love to train software developers in our licensed coding boot camps, as well as to build custom software solutions for companies. So reach out, because we'd love to help. Check out startuphack.com/Spencer, and here's some great information about some of the services that we can provide.
Hi, my name is Spencer Thomason, and I'm a fractional CTO. With over a decade of executive leadership and a solid 25 years in software development, I've mastered the art of transforming technology teams and products. So what is a fractional CTO? This is where you can contract someone like myself to come into your organization and get the benefits of a seasoned CTO without having to employ me full time. In today's fast-paced world, efficiency, security, and product scaling aren't just goals, they're necessities. My passion is building impactful products and enhancing organizational efficiencies through technology. From startups to small businesses, my approach leverages lean methodologies to not just meet but exceed your strategic goals. Whether it's through executive mentoring, cloud system architecture, or launching a minimum viable product swiftly, my aim is to make a significant impact right from the start. Recognized in the Arizona startup ecosystem, my journey has been about creating value and fostering innovation. I have led technology for companies like GoDaddy, SRP, and Wells Fargo, and turned challenges into milestones. I've taken this learning and launched 7 of my own brands, and now I want to help you. So if you're looking for a fractional CTO who brings a wealth of experience, strategic vision, and a proven track record, let's connect. Together we can build technology that not only drives your business forward, but also makes a difference. Technology leadership redefined to fit your needs. So reach out today.